So if you look at those 10 different checklist items that the EPA recommends, they largely fall into 4 categories in what we call converged security solutions, right? And the first thing is the ability to discover everything on your network. So whatever solution that you have, and Sectrio does this really very well, is to do this in a passive way. So today, many of those OT or process control networks don't necessarily, they don't necessarily know, not many people know what is there on the network. And if you look at an IT asset visibility software, they do it in a very intrusive manner. They actually ping the device, they try to figure out information from the device, and that's what we call active discovery. Active discovery is not necessarily something that works very well in the OT space, and what we need to do is something called passive discovery, and OT solutions are very good at passive discovery. So without actually hitting the network, just by looking at the network traffic, what is coming out of those devices and how they're communicating, the ability to classify the device and say, okay, this is that device, this is the OS and operating system, and this is the firmware that's running. We also see that it has some kind of an antivirus, and that antivirus is of this date. The system itself is end of service or end of life, and listing out all the particular vulnerabilities that exist on the system is what good OT systems do. So it gives you the lay of the land of what you are trying to protect. What assets exist out there, how are they communicating with each other, which services that they're using, what protocols they're using, and when you notice the protocols, you also understand what network level attacks could occur, and hence, because the protocols themselves are so old that they have vulnerabilities that could be exploited. So it gives you a good attack surface of your complete OT network. And that is the first step. Even the EPA is basically suggesting, right, in terms of discovery of your whole network, knowing your assets and your vulnerabilities. Once that is identified, you are trying to mitigate or reduce that attack surface. And the way you do that is through Vlan segregation. The EPA calls it specifically of segregating your enterprise, your control system networks, and your mobile networks. But they also go and make recommendations of whitelisting and things like that. So the ability to micro-segment that network non-intrusively. Without, many of these networks contain unmanaged switches. So it's not easy to deploy a VLAN solution without actually pulling out equipment that already exists. So you may want to actually put a solution that is capable of segregating or micro-segmenting the network to the degree that you can go out and identify the device, the service, and say, hey, this particular asset talks to this asset only on this particular service. And that is the micro-segmentation piece that needs to go in. The third piece is obviously the detection piece. Today, a lot of OT security solutions are looking for what we call tags or process control commands that are going out from specific programs or assets that are trying to, for example, change the state of a valve, right, to open or close, or change the pressure sensors, or or some actuator down the line in the water utility. Now, that if there is a tag that is going out which typically is not seen, or you're seeing a new file being downloaded on any asset, all of those are what normal OT security solutions do, but they are all post facto, in the sense that you will see a bad tag or a tag trying to exploit a vulnerability only after a malware has actually come into the network, right? So when we are talking about detection, and when you're looking at OT security detection, you need to also look at signatures and heuristics, and these are patterns that we are matching for specific malware before they actually enter into the network, and able to flag that off. We are not necessarily wait for that malware to get resident into the network, and then when it is trying to instrument do something in the network, you're basically detecting it. By then you're already too late. So the ability to detect that whole attack vector as it occurs, or indicator of compromise as it's occurring, is a very key differentiation that most folks need to look in an OT solution. And the third thing is remediation or playbooks. So once you've discovered an attack, once you've discovered a vulnerability, the OT IT world, while the networks are converging, the folks and the skill sets are yet to converge. So IT folks don't necessarily know what needs to happen on an in an OT network to remediate any of the vulnerabilities or remediate any threats without actually, I mean, the risk is to actually impact the process or the control that is running that water utility. And the OT folks don't necessarily know enough about, IT or cybersecurity to even say that, okay, this is a known attack. So where you need the playbooks and the remediation plans and the SOP, standard operating procedures that the EPA is basically suggesting, have to be built into that OT solution. Essentially, for them, for you to instrument, solutions or remediations on the network as and when you see things occurring, without the risk of actually taking the process down, right? And to do it at a low risk situation, and to do it consistently and make sure that it's effective. So that's where playbooks come into the solution. Those playbooks have to be, specifically designed and orchestrated for that particular utility, because not all utilities are different. There are different, OEM or suppliers of different equipment. Also, every utility has their own code running it, because they run on programmable logic controllers, and by nature, it's the program that runs on that controller that makes that controller behave. And it's not the same as having a Windows machine, but knowing the specific code. So orchestrating and basically implementing that playbook specific to that network, so that you are able to not create a response plan, implement a standard operating procedure, and make sure that there's uniformity and a very low risk to actually impact the control system, is a key critical component